Welcome again to the channel. Today we'll be solving LeetCode question number 547, number of provinces. Let's understand what the question is saying. So basically we have n number of cities, basically 1, 2, 3, 4, right? And if city A is connected directly to city B and city B is connected to city C, then city A is connected indirectly to city C. What this means is we'll have numbers like 1, 2, 3, dot dot till n, right? Now it's saying if there is a city A which is connected to city B and that is connected to city C, A is also connected to city C. How is this represented? It is represented in the form of a matrix, right? So let's have 0, 1, 2, 3 and 0, 1, 2 and 3, right? Okay, now let us assume that this is city 1, 2 and 3. Now since it is given that A and B is connected, that means 1 is connected to 2, so 1 comma 2 will have a value 1 here. That means they are connected. And similarly 2 comma 1 will also have 1, right? Because city 2 is also connected to city 1. So it's not a unidirectional arrow, it will be a bidirectional arrow, right? In the same way, since 1 is connected to 2, 2 is also connected to 1, and then 2 is connected to 3, so that means 2 comma 3 is 1, and so is 3 comma 2. Sorry, this will be 1, right? Now A is not directly connected to C, right? That means here 1 is not pointing to 3, because we can see 1, 3, that is not 1, right? That will be a 0. This will be a 0, and similarly 3 comma 1 will also be a 0. But since A is connected to B and B is connected to C, A is also connected to C. It's not shown in the matrix, that's a different thing. In the matrix it says 1 is not connected to 3, but we know indirectly 1 is connected to 3, right? So that's why this line is important here. Now next we see a province is a group of directly or indirectly connected cities and no other cities outside the group. That means if there were a city 4, say a city 4 here and a city 4 here, a province in this case would consist of only 1, 2 and 3. These 3 cities would make one province and the 4 alone would be another province, because the city 4 is not connected to any of the other cities, right? 1 is connected to 2, 2 is connected to 3 and 1 is indirectly connected to 3, and none of those connections have 4. So 4 alone is a province and the other 3 are grouped together in one province. So in total there are 2 provinces here, right? Not 4 but 2. Now this paragraph just states whatever we have seen here, right? We are given an n cross n matrix and its name is connected, where is connected I comma j equal to 1, like here. Those will be 1 where I and jth city are directly connected, not indirectly, right? So that's what I said, that 1 and 3 are not connected directly, right? They are connected indirectly. So that's why the cell of the matrix representing 1 comma 3 is a 0, not a 1. Even though it's a 0, they are connected indirectly and they will be within the same province, right? And is connected equal to 0 otherwise, right? Return the total number of provinces, right? We have to return how many provinces are there. In this question there are 2. All these 3 are within the same province and 4 alone is another province. So in total in this matrix there are 2 provinces, right? Now how will we solve this question? Let's see. So here I have drawn a matrix, right? let's say 1 comma 2 comma 3, oh sorry, let's say 1 comma 2 comma 3 are in a province and 4 and 5 are in another province, right? So how can we count the number of these two provinces? The answer is 2, right? So what we will do is we will iterate from 0 till n. This is the nth value, right? I mean n minus 1 in this case, uh, but no, it's actually n only, correct, sorry, right? We'll iterate to n, and whenever we encounter a province, the first one in this case will encounter is 1, right? We'll increase the province number. Let's say p equal to 0. It was initially 0. We encountered 1 and it became 1, right? We encountered one province, right? Because 1 alone could be a province. It might have another cities included within the same province, but when we encountered 1, we know we have encountered at least one of the provinces, right? So that's why we increase the province number. Now what we can do is, since 1, 2 and 3 are connected somehow, we will migrate from 1 to 2, right? We will migrate from 1 to 2 and we will mark 2 as visited. So that means this city 2 has been visited. This city 1 has also been visited, right? And from city 2, we'll migrate to city 3, we'll move to city 3 and mark it visited as well, right? There will be some connections, like 1 will be connected to 2, 2 will be connected to 3, right? We might not be able to travel directly from 1 to 3, but indirectly we will reach all the cities within the same province that are connected, right? Now when we move along with the iteration, we were iterating, remember, we were moving from 0, right? We were in 1. Now the next point we'll reach is 2 and we'll check if the city 2 has been visited or not, right? We'll check if the city 2 has been visited or not. If it is visited, we'll move on directly to the next. We'll not check for city 2, right? Because it's already within our province. And also we will not increase the number of province here. Why? Because it is marked visited. That means in some other province it is already included. City 2 has already been included in some other province. So we will not increase the province number here as well. And that's how we'll keep on moving from 2 to 3 and then 3 to 4. We see 4 is not visited yet. So now we'll have to increase the number of provinces. This will become 2. This will be visited. And from 4 we move to 5 and that will be marked visited as well. And after the iteration ends, we are left with provinces equal to 2, right? How will we accomplish this? Via DFS. DFS is a common graph traversal algorithm. We'll implement that and we'll traverse from 1 to 2 to 3 and similarly from 4 to 5, right? So let's write the code for this. Now the first thing we need to find is n, right? Since we are traversing from 0 to n, right? And n will be length of is connected, as you can see here as well. Here n is 5, here also n is 5, right? So n will be 5 and we are also, even in the question it is given, it is an n cross n matrix, right? So length of is connected will be our n. Then what will we do? We'll iterate over the n, right? So for I equal to 0, from 0 we'll start I less than n and I plus plus. We'll iterate till n minus 1 basically, right? And for each city, as I said, we'll check firstly if it is visited or not. If it is visited, we'll do nothing, right? So we'll check if not visited of I, right? If the city I is not visited, only then we'll have to do something, otherwise we don't, right? So if the city I is not visited, then we'll mark it as visited first of all. Visited of I equal to true, and then we'll run the DFS algorithm for the city I, right? Also, we will increase the provinces. Remember, provinces plus plus, right? Since we hit first one here, we increase provinces, remember, and when we hit 4, it was not visited, and we increased the provinces again, right? So whenever we hit a not visited city, we have to increase the number of provinces. Whenever we hit a not visited city, we increase the provinces, right? Now, first of all, we need to declare the visited array. So visited will be array of boolean, and in the length will be n, right? Because there are only n cities, right? So we need to find out or keep track of if n cities are visited or not. So that's why the length of the array will also be n, right? Then of course we'll have the provinces int. Next we have to write the DFS function, right? So var DFS will be a func, and it will take an int, right? It will return nothing, right? Now DFS equal to function, it will take the city, right? Now what do we need to do, or what we did actually, whenever we hit a new not visited city, we moved to its connected cities, right? Now the connected cities can be only within these numbers, right? So if there are n cities and the value of n is 5, the cities will be 1 to 5, right? So that means a city 6 cannot be there, or city 10 cannot be there, right? So the city value will be also within n. So that means within the DFS function, if we are trying to move from one city to another, let's call the another city its neighbor. The neighbor city, the value of the neighbor cannot be more than n. The value of the neighbor will also be within this range only. So that means within the DFS function, when we are trying to move from one city to its neighbor, we also have to iterate till n. So that's why for neighbor starting from 0, because 0th city can be a neighbor to the current city, right? And neighbor less than n. So any city from 0 till n minus 1 could be a neighbor for the current city. Neighbor plus plus. Now we have to check if this neighbor city is actually the neighbor for the current city, and where is it determined? It is determined in the is connected matrix, right? If the value for that is 1, that means they are truly neighbors. So we'll check if is connected city neighbor, right? If it is connected, and that means if it is equal to 1, they are neighbors, and we can move to this neighbor, new neighbor, right? So like we cannot move from 1 to 4 because there was no connection, right? 1 was connected to only 2, so we move from 1 to 2, right? So that's why we have to first check if they are connected or not. If they are connected, we can move into the new neighbor city. Another condition that we need to check is not visited of neighbor. The neighbor city that we are trying to move into should also be not visited, right? It should not be visited. Since we are moving into the neighbor city, the visited of neighbor equals to true, and again we call DFS on the neighbor, right? That's what we do. It's like moving from 1 to 2, and then into again calling DFS to move into the third neighbor, right? And in the last we return provinces. Let's check if this solution works or not, and it seems to be working. Let's try submitting it, and it is working. So this was the DFS solution of this question. There's another method of doing this, which is the union find, and maybe I'll post that solution in the next video. So see you next time.